we just talked about the central limit theorem, and now I'd like to do some problems with you. Let's start out with problem 2. So I think 2 is very good. This is on roughly page 136. So in problem 2, we have 8 machines that operate independently of one another. So this independently, by the way, is sort of code word for sampling with replacement. So all the machines are independent of one another. The mean production rate for each machine is 20.3 tons per day, and the standard deviation is 1.4 tons per day, and the distribution of a single machine is normal. Let's go take some notes on this. So I'm going to start out with the random variable. So the random variable, call it x, is the output from a single machine. Now we've been told that the expected value of x, or the mean of x, is equal to 20.3 tons. We've also been told that the standard deviation, so how much does this vary across day, is equal to about 1.4 tons. And we also know that x is approximately normal. So the little tilde means distributed. So x is distributed normally. Let's read on. So how much do you expect to produce in total from the 8 machines? And approximately how much uncertainty is there in the average daily production for all 8 machines combined? All right, so the way to think about what this is asking is I turn on the machines. You can think of that as a random experiment, and I let them produce for the day. And each one of these machines is going to kick out about 20.3 tons, but that's going to vary. Now I'm going to add up the total amount from all 8 machines, and that's how much I have to ship at the end of the day. So the question is, how much am I going to ship at the end of the day? So we have an n of 9, or n of 8, pardon me, 8 machines. My CH machines. And we're going to define a new random variable, which is t hat. So t hat will be the amount that we produce from the first machine plus the amount that we produce from the second machine plus all the way through, those are dots in here, the amount that we produce from machine 8. So this is the total daily production. And we're asked to find the mean of this total. So what is the expected value of t hat? Well, to answer this, let's go back to the slide that summarizes the results for sampling distributions. And here it is. The mean of t hat is just n times mu sub x. So from that, we know this is n times mu sub x. So 8 times 20.3 equals 162.4 tons. Now, you probably didn't need statistics to guess that, but that's what this formula says. So sometimes it's kind of good to apply it to an obvious thing. The standard deviation of t hat is far less obvious. So let's go back to the course packet. And what you'll see is that the standard deviation of t hat is given roughly in the middle of the page, is just sigma sub x times the square root of n. So this is going to be sigma x times the square root of n, so 1.4 times root 8, and that's equal to 3.95, 3.96 actually. Let's round that to 4. And then let's think about the interpretation. So the distribution of the total is going to be approximately normal. How do I know that? Well, I know that from the normal theorem. So the normal theorem says if the population is normal, which it is, then the sampling distributions of both t of x bar and t hat will also be normal. Now the mean of this distribution is 162.4. Now from this standard deviation, we can conclude that 68% of the time we'll be producing between 158.4, so that's one standard deviation to the left, to 166.4, which is one standard deviation to the right. And so that's a fairly powerful result. Now the rest of this problem discusses x bar, which is the average production per machine. So if we take the amount that we make from all the machines, add them up, divide by 8, we're going to get this x bar, average production per machine. Per machine. Let's make sure I get that right. Now the expected value of x bar is also given on this slide, and we see it's just mu. So on the average we get the truth. So the expected value of x bar is just the mean of x, which is 20.3 tons. That's a 3. The standard deviation of x bar, however, is a little bit different. It's going to be sigma sub x over root n. Where does that come from? Well, it comes from this slide, sigma sub x over root n. So let's go plug in the numbers. This will be 1.4 divided by the square root of 8, and that equals about 0.49, and the interpretation will be similar. And I think we've answered all the questions.